Hello, my name is Salam. I'm going to today to speak about uh, my dissertation topic, automated computer vision system for real-time hand engine compliance tracking. I'm using in this technique two type. I'm using XG boss technique using webcam camera and also RGB depth camera. We will go through our presentation. We'll speak about this outline point, our background and modification, literature review, and research aim and question, methodology, physical testing and discussion, and future work what we'll do. We'll speak now about the background. As we know what is important of the hand hygiene technique, especially in healthcare system, as we can see from the result or research, that's 135,000 annual HAI deaths from in Europe only affected by not using hand hygiene technique well. It is used already, but is not efficient as we expect. Up to 40% compliance rate among healthcare workers. We can see here our aim is to develop and evaluate, also compare an automated real-time computer vision system, which for according to WHO seven steps. We will use in our system the 7 steps, and we will use only CPU, not GPU, as it is cheaper than GPU. And in our machine learning, we use ST20312571. This is our question: which machine learning will be working well, or deep learning, and you have smart be helpful, as well as we will implement and use RGB depth camera from Orbit Gemini 336, and also we will check using yellow V8 plus by LSTM it will be affected or not. In our literature view, as we saw, there is three type of scenes. Image, you can use image based or temporal sequential model, and landmark skeletal base. All of them has a gap in between, and we use XG post to cover this gap. Why I used XG post? Because there is limited, or no one used except one paper spoke about it using sensors, but this is only one related to computer vision technique. Here we can find the algorithm, how it is working. XG post, how it is working. It is extracting the features, and we have a tree of from 500 gradient. We use softmax, SMOT, personalization, and as we said, we use CPU, not GPU. Here we can find the media pipe 21 landmark, how it is working, and the distribution of left and right landmark. If we go to for the philosophy and design, here our technique, a quantitative experiment, deductive and positivism, computationally we are using CPU, primary plus secondary self collected from ICU, and also we used Zenodo technique for comparability. That's set used in this. We use SunnyDep open source on GitHub. We use the 19,000 landmark. It subject video, we use the 3-camera view, and I used all of them at the same time so to get high collection, because that set is small compared to Zenito. Zenito is used 3,100 more than around 200 episode, so it's around 18 GB as a bulk dataset. Here we can see the pipeline, how it is working. We have a 4 layers technique. We used here the layer for the camera, Orbic or laptop. Layer 2, the media pipe and extracting the features, and 126 float. We used XG boss 500 for 70 classes and voting. Third layer, it is real-time output feedback. We get it, as we can see here, how is the pipeline, if it is came from through the laptop or RGB camera. Here we train a lot of models to see which one is accuracy and compatible to us. We use SVM. This is used by Sunny Deep. We used logistic regression, CNN transformer plus transformer, CNN plus LSTM, XG post, SMOD, and here we can see our technique, how it is get a high result. We with XG post we reach 96.75, around 97%, better than the other models. Here we can see the graphs, how it is. We have here the best model. We extract XG post, as here it is CNN plus transformer, and also NN plus LSTM. Here logistic regression, and we can see from the graph that it is the best one. It is XG post. Here how we can see how is the process and real-time feedback. Each step has counted directly. Once you finish one step, it's coming to the second. Once you finish the second, going for the third. Once completed, here is recorded. It's not clear as too much, but it's recorded and telling you what exactly to the times. Physical testing, here you can see how is the system working. Here in the laptop webcam camera, detecting at the real time, detect the 7 steps working well or no, how it is working. Once it's finished, complete the process, it is detect and will be checked, as we see. We saw that as a previous slide. Here Orbic camera, and we saw with it is 100% is completed, and also by using Orbic camera, the results is too much better. Here how is the novel XG post application. It is Pioneer, is unique, and also we use the quantification, first quantification frame-based generalization. CPUs only, which will save time and money. Also temporal model, and we use RGB camera, which valuable, and we working with 10 frame, and also we will increase for 30 more frame. Limitations: media fail under SOAP and form, small control training dataset subject. We will try to use bigger datasets than better, and classified also the set is better than a general video and something. Single user personalization. As we see, how is the weak? The strength is 97%. Is weak with form and personalization. We'll improve later using different technique, and also use different type of camera to check them. A recommendation for the future, it is using, as we said, it is using different camera, embedded, trying this technique that's used by Draco, was using NVIDIA just on Nano. Try to work on the phone, and that's working well. That is at the finals we can so our technique is success with better than the others module with 96% or around 97% real-time feedback, complete the sessions with laptop webcam or camera or big camera from Gemini. Thank you for your support and for your listening to our presentation, and thank you.